Hello everyone. In this presentation, I'd like to explain my understanding of a concept that we may often be faced when we are flying into our destination. This concept has to do with the vertical speed and the vertical profile of the aircraft. And I'm going to give two scenarios. One, I'll be explaining, first of all, using a presentation in written form, as you can see on the screen, for both scenarios. And then we're going to jump into the Majestic simulator, which I often use, as you might be aware of, to demonstrate a couple of things that are pretty much near the real aircraft operation. So what we want to explain here is something to do with the vertical speed that we use on the FGCP using the thumb wheel after engaging the vertical speed push button, and the vertical speeds that are given on the FMS page of the VNAV VTO vertical 2. And we just want to describe these concepts in two scenarios. So let's look at the first scenario. I want you to listen very carefully, and apologies if some of the things might be in a bit of an error, but I'll try my best to explain to you in the best possible manner on what I've been facing and I've been doing. So let's say, for instance, you are at top of descent, TOD, which is on the top right hand corner of your screen, if you can see the cursor moving. So you're at your top of descent, and before you reach top of descent, you normally request a descent so that you can set a low altitude on your FGCP with the altitude knob, and then you can engage all sail. And when the aircraft is approaching rather top of descent, maybe around 2 minutes before, 1 minute before, you can start seeing the vertical profile on the PFD dropping down towards the center as the aircraft tries to catch up its vertical profile, which on this diagram I've shown in red. Now let's say that the ATC is delaying your descent. Okay, so the ATC says standby descent because of traffic restrictions. They don't want to give you a descent at that particular point because they might have already given a descent to another traffic, or there's a conflict somewhere. So they want to keep you a bit high and delay your descent so they can clear the other one to a safer altitude before they can allow you to descend, maybe through the level and the like. So anything like that is possible. So now, later, what's going to happen, if they delay your descent, you can clearly see that your path will be maintained by this black dotted line until a certain distance. Okay, this is not to scale, so although it's small, but it can be a big distance. Let's say 5 miles or 7 miles. Okay, rarely 10-20 miles. I don't think that's going to be very practical, but you can really go quite far from top of descent. So from you visualizing this in your heads, you will realize that you will become higher. You will be above the FMS descent path, okay, which is programmed the FMS. The FMS descent path is programmed, let's say for instance in our case, from top of descent all the way down to the final approach fix. This is just for our explanation purposes, so I don't introduce a lot of waypoints and all that, but it applies the same to the whole concept. So let's say in a simple scenario, you want to descend from top of descent all the way down to your final approach fix, or maybe the ILS glide stop capture point, the platform altitude point where you want to capture a glide stop from. So for some reason you have been told to stop, to halt on your descent. Means the aircraft is going to now come here. Now let's say here, now they say, okay, you are clear to descend to a low altitude. What you can do, there are two things you can do here. Because you know you are high and you want to lose altitude, you can orbit. Okay, so you can go heading select and you'll request that can we please orbit until we catch up with our descent profile, because we are high. That's one thing you can do, which is perfectly okay as well. It's not a problem as long as there's no issues of traffic on your left or right sides, or there is no terrain and the like. Likely at that altitude you won't get any terrain. It's very impractical, but if there's no issues, you may orbit and you can start descending in the orbit while you reprogram your FMS to capture the vertical profile. Okay, that's one thing. Another way of doing such a maneuver is to engage vertical speed. Now, when you engage vertical speed Vs on your FGCP, you will have to descend at a very high rate of descent, like say for example 3000 feet per minute, for instance. This also depends on how high you are. If you are very, very high, let's say 25,000 feet or thereabouts, you can definitely use that vertical rate of descent because you're not in any conflict with terrain. So you will set a vertical speed of, let's say, 3000 feet per minute. Okay, what that's going to do is that it's going to drop you down all the way past your FMS descent path. If you can see in the green, this is you bombing down in a sense, okay, all the way, okay, until you are below the FMS descent path. Now, when you do this, what you have to do is that you've got to go and keep the FMS VNAV VTO page on your display of the FMS. And then all you do is that you keep doing VTO to, let's say here, the final approach fix. And each time you keep doing that, you will realize that it's telling you to reduce your rate of descent, telling you that for you to get back on the FMS descent path, you have to reduce your rate of descent so you can pitch up and capture this path. Okay, I hope it's making sense, because you are already below the FMS descent path in this region here. So for you to get back onto this FMS descent path, you have to reduce rate of descent. Now, why would you do this? Well, if you had to VTO from here, for example, from where you are now starting your descent, where you are well above your the FMS descent path, okay, your FMS descent was calculated at top of descent, which is programmed into the FMS, but because of some reason you delayed your descent, so you became above the descent path. Now, if you have to do VTO all the way to FAF, okay, using FMS, which is perfectly okay, the aircraft will seriously dive, okay, and it's going to come at a very, very high rate of descent and therefore a very high speed, so that when you are in the vicinity of the final approach fix, you'll be way above 200 knots, meaning your configuration speed, okay, and which is not practical. So what you do, you would either orbit, as I said, or if you use a vertical speed function, you're going to engage vertical speed, set a higher rate of descent, go all the way down the vertical FMS descent path, okay, and then you keep checking whether you are getting a suitable value, let's say 1500 or 1800 feet per minute, which is our normal rates of descent, to get back to your descent path. Because obviously here you'll be in let's say 3000 feet per minute, okay, for example, all the way down here. Now if you keep checking your VTO page, the VTO page of the FMS will tell you that for you to get back onto this path, reduce rate of descent. So using your thumb wheel, you'll start reducing your rate of descent, okay, and then the aircraft start pitching up all the way up, and you'll see the VNAV profile coming in view on the PFD, and once it's just above your profile, you'll engage VNAV. In that way, the aircraft will capture once again the FMS descent path, okay, with a suitable speed on which you will follow all the way down to a final approach fix, and before that you'll do your configuration, okay. So what happens here, what I've said in this box here, is that the higher the rate of descent you set, okay, compared to the rate of descent that's already been programmed in the FMS, your rate of descent on the FGCP, if it's high, the vertical speed to the same point from the FMS will be low, because the FMS still wants you to get onto its calculated 3-degree path, which is the red one here, okay, and for you to get to that path, you have to reduce. So once you are here somewhere, reduce rate of descent so aircraft can pitch up and catch this FMS descent path, after which you can follow it all the way down with a suitable speed, okay. This is the whole point of the VTO and the vertical speed relationship of this aircraft. This is one scenario. So let's go ahead and see how this appears in our explanation using the simulated format. I'll definitely try my best to explain to you the same thing. Of course, you must remember that the FMS on this simulator on the Majestic is a bit different to the real one, but it shows you exactly what you want to see. So nonetheless, it's all good. After this, we're going to now talk of another scenario as well, and also then use the simulation to show the example. So let's jump into simulator now. Okay, so here we are in the Majestic simulator. I've just paused the simulator for a moment just to go through a few bits and pieces. We have, let's say, the approach speeds already set here, go around speed and the VREF speed. The minimums we'll be using, again, we are practicing in the long way. So we are coming in from the southwesterly direction, and we're going to be using runway 14. So the minimums will be 4420. And what we have, where we are right now, we are approaching at least 1 minute from our top of descent point. Now we are maintaining 25,000 feet with alt mode and LNAV mode. So what we're going to do, deliberately we're going to delay the descent. So we're going to pass our top of descent point, and then I want you to observe what happens to this V-path indicator. Apologies, as you might understand, this software sometimes can have issues depending on the system it's being operated. Like for instance, I'm maintaining 25,000 feet right now, but because I've paused the simulator, it's showing that it's climbing. But this has nothing to do with it won't make any difference to explanation, not that much. In reality, of course, it has to maintain 25,000 feet, but because of the software issues, you might understand, sometimes you're unable to control this. But I want to make sure that the main purpose of this presentation is shown to you in as far as the relationship between the vertical speed on the FGCP here, which I've also kept it on the display, is connected to the FMS VTO function once we execute it. So I'm going to freeze the simulator now, and then we will see what's happening as we come to our top of descent, and let's look at what's happening. I'll talk you through it. So there we go. I've unfreezed the simulator now, and we are coming top of descent point. As I said, please don't bother about this vertical speed indicator on the PFD. It will stabilize once the software knows that it's stabilized. And as we're coming close and close and close, you will see what's going to be happening on this V-path indicator. Eventually we come always under the vertical profile, as you might be aware of, and we capture any vertical profile, be it the ILS or be it the RNAV, like what we're doing here, from below. So let's just wait and watch and see as we approach top of descent. As you can see what's happening. Each time I pause the simulator, you might see a fluctuation here, but please don't take that into consideration at all. As I said, it's just a problem with the software sometimes. So I haven't been given a descent altitude right now by ATC, so I'm still at 25,000 feet. I've been told to stand by. So here I come over top of descent. Vertical alert, and look at the V-path indicator now. Can you see what's happening? We are coming below it. If we were given a descent, we set low altitude here with wholesale with VNAV path, it will start going down. But right now we can't. So there we go. Now we're going above the vertical profile. Can you see we are getting higher, and we are getting higher, and we are getting higher, as you can see, and we're going to get quite high until this will disappear from view. Once that happens, I'll keep it a bit for a while until we are at a suitable distance from the top of descent. And now we've got very high here. We are 48 miles from our initial approach fix, which is Utuga, and we are quite high. So I'm going to pause the simulator here. So I've paused it. Don't bother about this, I keep saying that. Right, from here, because of course in reality you don't pause the aircraft, but here, because I want to explain to you in step by step. Now let's say the ATC comes and says you are clear to descend to, let's say, 7,000 feet. Okay, So what I'm going to do, I'm going to set 7,000 on the FGCP altitude mode, knob rather. Sorry about that. And 7,000, there it is. And obviously we always set with all cell. Okay, there's a message here on the FMS flicking which says all alert above VNAV also. That's making sense because we have passed the top of descent. Now we have set 7,000. Okay, we are very high and we have to go below the FMS vertical path, which is obviously won't be shown on the MFD because we always see the plan view from the MFD. But if you go back to the explanation I showed you, there is a vertical path, a slanted line from the aircraft all the way down to the next waypoint. In this case, we were descending to Utuga, to be at Utuga at 6700. So how are we going to get back onto our FMS path? As I told you, we can either orbit and descend in the orbit and then capture the path from underneath, or we can use vertical speed. Here we are going to use vertical speed. So what we're going to do is that I've already set 7,000, the altitude given to me. Now I want you to see this VTO page. If you see the VTO page, from where I am right now, if I want to go to Utemi, I have to descend at a descent rate of 1,677 foot per minute. Okay, that's very important. So what's going to happen, I want you to see if I increase the rate of descent using vertical speed with a thumb wheel, look at this number here and you will realize that it will be decreasing. Okay, I could just go a bit further on, maybe this is a very small rate of descent. What I can do, let me just maintain the altitude. So I'm going to press Alt mode. Okay, I'll just press Alt mode here. I'm not going to set anything, and the aircraft won't descend until I go higher and higher and higher. Let's see if that works out for us. So I'm not going to descend. I've just maintained altitude there. It shouldn't be descending at all, actually. It's just adjusting itself. Now look what happens here. Can you see Utemi here? Look, the higher we are getting, it's telling us that for us to get to Utemi, we have to descend at this rate here. Now it's 1725, 1730, 1735. Can you see that these vertical speeds are increasing? Okay, you can clearly see that. And if we maintain a higher altitude like this, if we engage VTO, the aircraft will really dive and we will not be able to configure by the time we reach the final approach fix, because high rate of descent means high indicated airspeed. Okay, you can see it's going to 1800 now. There we go. Okay, so I'm still maintaining this, and now I'm going to pause the simulator there. Now I want you to see what happens when I do vertical speed. There's vertical speed, and I'm going to set a very high altitude rate of descent, rather, with, let's say, 3,000 feet per minute. So 3,000, there we go. Let's make it 3,000. Oops, that's just getting, hang on, vertical speed. What's happening here? Vertical speed. Let's try it again. And okay, that's a bit too high. Maybe 3,000 feet per minute. And I press all cell. So now when I unfreeze the simulator, look what happens. We've set 3,000. Now this has to reduce. So, and then you'll even see that the vertical path here will be coming up as we are trying to go underneath the FMS vertical profile. So I'm going to unfreeze the simulator. And it has to start descending immediately from now. Now let's see what happens. There we go. The aircraft is now descending. I have to reduce the power. Let me just reduce the power so we don't go to very high torques here. A bit of a delay in response here. I don't want to go into the red bar at all. You can see we are descending. Okay, and I'll maintain a suitable speed here. You see we're very high, so we're going to go all the way below the profile. Once we are below the profile, look what's happening here now. Can you see now it's decreasing? Now we are below the profile. The moment this starts decreasing, now we are below the profile. So you can clearly see that now we are below the FMS profile, but we are doing vertical speed. Okay, you can see now it's 1998, 194. You can see this reading here. Keep your eye on this reading. See, it's decreasing. Okay, it's telling us that for us to get back to the vertical profile, we have to use this rate of descent of the FMS rather. So until we can get our, I can still go a bit more because I'm coming close. So I'll go to 3,500 feet per minute. Let's see if that works. I'm pretty sure it should work. I think I did go very far. We can go a bit to 4,000. And here we go. You can see this is decreasing to 1.8 now. So this is what I wanted you to appreciate. Okay, that the higher vertical speed we set on the FGCP, the lower the vertical speed that the FMS tells us to get back to its calculated vertical profile from where you are to where you want to go. And we just used the Utemi here. We're not going to enter, we just want to see what's happening. So that's why I haven't put anything here, I haven't VTO. This page is just for reference now. Look at this vertical path. Here it goes. Here it's coming. Can you see that? It's coming. There we go. Alright, now it's coming. So when it's coming now, what's going to happen is that we're going to start decreasing our vertical speed. So now we're going to start decreasing. Oops. There we go. We are above the profile. There we go, above the profile. Now I'll stop there. Okay. And now I'm going to set a vertical speed. Okay, I'm going to set a vertical speed equal to what's given to me on the VTO page. Okay, that's what we do now. So I'm going to go, excuse about the clicking, I'm using the mouse pad here. So I'm going to set, let's say 1500. So now I'm going to pitch the nose up. So again, I want to tell you something. We were descending at around 4,000 feet per minute. Okay, we dip down the FMS vertical profile, and the higher the vertical speed which we set on the FGCP, the lower the vertical speed is given to us to capture our 3-degree path from the FMS. So now the aircraft is telling me that for me, from here, for you to go to Utemi in a good configuration, decrease the rate of descent to 1,600 feet. Okay, we've just gone 1,500 because can you see the vertical path indicator here? We are below it now. So now we are perfectly okay. So now when I do this, the aircraft starts pitching up. So as the aircraft pitches up, there is a lag a bit in the software. Still going to go down. Now it's pitching up. Can you see it's pitching up there? Now it's pitching up, and then I can engage VNAV. Okay, I'll engage VNAV now. So VPath. Alright. Now you can see that the aircraft now will pitch up. Okay, and it's going to try and capture the vertical profile. And as it's doing that, the speed, you can see the indicator is also decreasing to a suitable value. Okay, as you can see, and before we reach our initial approach fix, initial fix, we should be around 200 knots, and here we are. We have captured the vertical profile of the FMS from below using vertical speed, using FGCP vertical speed, and referencing our values to the VTO page to where we are going. So now you can see the speed is bleeding off nicely. Okay, I can still come back a bit on the power. Alright, and I've captured the vertical profile. There it is. Okay, just at 10,000 feet above the airport elevation, where I can start putting my lights on, seatbelt signs to recycle, doing my approach checklist. Okay, and there we are. So there was no need to panic if the ATC delayed you for this descent. Okay, and just before Utuga, you're 18 miles from Utuga, you are comfortably decreasing speed to 200 knots and below, where you can start now configuring for your flaps just at Tortuga or thereabouts. Here, when I reach 200 knots, I can start adding a bit of power to maintain 200 knots, and then the rest of the flying is just going to be as it is. Now you can see that the 1,500 feet here is 1,100 feet. So this vertical speed and this vertical speed are inversely related, okay? Because if I can pause the simulator now, this vertical speed here tells you that from where you are to get to Utemi on a 3-degree path, you have to have a rate of descent of 1078 feet per second, feet per minute, feet per minute. Okay, if you're going to reference your waypoint to Utvag, which is initial fix, from where you are to Utvag, you got to have a vertical speed of 1295 feet per minute, and so on and so forth. I hope that's making sense for now in how you can capture the vertical profile of the FMS, the 3-degree profile, from wherever you are, regardless of whether you are starting your descent from top of descent or whether you have passed top of descent due to a delay, and then you can use vertical speed mode to get back. It's quite a maneuver, it's an interesting maneuver, but always bear in mind that you must have a good clearance from the ground. You cannot set high vertical speeds when you're near the ground for obvious reasons. So when you're high up there and you know that, okay, you're within your structural limits, you're able to do that. Okay, and that's about it for this presentation. Now let's go and talk about the other scenario using the same method, and let's see how that goes for you. Okay. Okay, in this second scenario, on the same concept that we are discussing about regarding the vertical speed we set on the FGCP and the vertical speed that the FMS dictates we need to have in order to descend to a particular altitude that corresponds to a particular waypoint. On this graphic, I haven't put any text besides the runway designation being X and Y. I just want to explain to you in plain language, and I do hope that it can make sense. But of course, you are free to ask me what I was intending to say or mean if you don't understand something in the comments. So here we are in a different scenario where you see the yellow star is where the aircraft should be, or the aircraft is. And in this position, the aircraft is already in the descent. And the ATC has assigned to give us runway X. Runway X is the furthest runway from our position. And the vertical profile that the FMS calculates, a 3-degree path from whenever we start our top of descent to the final approach fix, in this case, is going to be the line shown in solid red. Okay, so I'm saying it once more. We are already in the descent and we are heading towards the final approach fix of the runway X. Of course, after making some series of turns, but to make it a bit more simple, I've just used at one waypoint. Okay, I haven't introduced the initial approach fix. I haven't done that. Of course, we do pass through those, but I'm just trying to base my explanation because where I want to get to is again the relationship that exists between the vertical speed we set on the FGCP and the vertical speed we see on the VNAV VTO page of the FMS. Now, let's say at this position, the ATC comes and says we have a runway change. Okay, we have a runway change, so now the runway news is a reciprocal, meaning runway Y. Okay, so from present position, our whole planning was to go from where we start our descent all the way to X and land. But now at some point the descent, for some reason, maybe there is a wind change or there might be any other reason that says please plan to land on runway Y. So what do you know? What do you do? First of all, you realize a couple of things. With respect to runway Y, we are very high, and 2, we are very close. I'll say it once more. With respect to runway Y, which is closer to us, we are very high and very close. With respect to runway X, we are on a programmed vertical profile. Okay, so we are low, our rate of descent is also suitable for us to reach the final approach fix of runway X. However, because of the situation we're in right now, and the ATC tells you please plan to land on runway Y, we realize that we are high and we are close. So what are we going to do? Well, the first thing you can think of doing is that, okay, you will say we need to orbit and we need to request descent in the orbit to capture our profile from where we are to the runway Y profile, which is shown by the dotted line in this case. Okay, that's one thing we can do very comfortably. Make a nice orbit and come back and reprogram the whole FMS and prepare yourself to land on runway Y. That's one thing. But in this video, we are focusing our attention on the vertical speeds of the FMS VTO and the vertical speed we set on the FGCP using the thumb wheel and the vertical speed push button. So the moment we realize that we are close and high to this runway, what we can do, the first and foremost thing, go heading select and go vertical speed. Okay, those are two buttons you'll press on the FGCP. With the heading select, you will press it and you'll turn the heading select knob so that you are pointing in the direction of runway Y, somewhere in that direction of runway Y. That's the first thing you'll do, because you want the aircraft to go towards now to that direction and not where you're going. And the vertical speed, because you are high, you need to get down the vertical profile of runway Y from where you are. You are high, so you'll have to go all the way down, because if you do VTO from where you are to the final approach fix, by the time you reach final approach fix, you will be nowhere near your configuration speeds. You'll be very fast. Okay, you might end up in a hold to reduce speed and the like. Okay, so what you do, depending on how high you are, okay, set a suitable vertical speed that gets you below the profile, which is shown in green. Okay, and again, as in the previous video, keep the VTO page for monitoring. Okay, so the higher vertical speed you set, the lower the VTO vertical speed will be to tell you to get back to the vertical profile of that runway's final approach fix connecting to where you are. Okay, that's very important. So we will do this again using the sim, and you can just see what I'm trying to get to in this presentation. Okay, so remember, and the opposite is also true. Let's say, for example, you are planning to come on runway runway Y rather. That was your whole planning. From top of descent, you were planning to come runway Y. Now runway Y, from where you are coming from, meaning on the screen is from right to left, it's a straight in approach. You can see that you're coming in straight in into runway Y. But then the ATC comes and tells you that now the runway in use is runway X. Okay, what do you do in this case? Okay, now you know that you are low and you are far. Okay, as opposed to in the previous case where you are close and high, now you are low and you are far. So what would you do in this case? Would you increase the vertical speed? No, you will decrease the vertical speed, okay, so that you reduce your vertical speed, and after you catch your profile, you are now on a suitable profile where you can get to your runway and adjust the FMS. So before you go on and set up the FMS for the particular runway, what you should do is go heading select, vertical speed, point the aircraft in the direction of the runway you have to go to now as instructed by the ATC, and while you are in that mode, descending at a suitable rate, being whether you are close or far, you now start setting up the FMS for the particular runway, and then you can now engage the VNAV path mode once your path is at a suitable distance from your projected path. Okay, so let's see how this looks like in a presentation of the simulator. Okay guys, what you see on the screen here, I've just set up the aircraft in a descent. We're already in a descent to 7,000 feet. We are coming in from the southeasterly direction into Lilongwe. So I want us to appreciate one very important concept here. We are talking about using vertical speed to adjust for a profile change you may get. The first part was to do with a delay in top of descent, which made you come high, and then you had to catch the profile from below using vertical speed. In this second scenario I was talking about is when, let's say, you have a sudden runway change. So initially we are going from our present position, top of descent, and we've been cleared down to runway 14, which has a dog leg, so it's going to follow all this magenta path where the cursor is moving to Utvag, to Utuga rather, sorry, then to Utvag, then Utemi, which is a final approach fix. Now the reciprocal of runway 14 is runway 32, which is on this side of the airfield, as you will appreciate. Now here, just bear in mind, I haven't set any minimums or anything because that's not our point of interest. Our point of interest is to just appreciate the vertical profile and the rate of descent. Now let's look at this. Of course, a Majestic FMS is a bit different somehow than the real one. Maybe it's not updated, but it does show you what I want to actually explain. So let's look at this. From here we're in a descent in VNAV path. We are descending 7,000 from 20,000 feet. So I started this sim when we were in a descent. Now if you can see, from our present position to reach Utuga, which is our initial approach fix, we require a descent rate of minus 1,783 feet per minute, or 1,783 feet per minute going downwards. The minus means going down. Now let's try and do something here just for you to appreciate. Remember, this figure is 1783, okay, from here all the way to Utuga. Now let's say we have runway change. So let me program runway 32 in the FMS, and then let's see what the vertical speed will be to the initial approach fix runway 32, which I know it's called APLOL from our direction. All right, and then just appreciate these two figures, and I'll tell you what we're trying to explain here. So let me try and change runway 32. So menu, arrival, and we go to Lilongwe, runway 32 this time. So that's number 2. I'm going to select number 2, and then I'll press enter. Approach is not needed. We will do the RNAV 32, which is number 1, and then I'm going to press enter again, and then it's going to give me the initial approach fix selection. I'm coming in from southeast, so I know, because I fly to this airport, it's our base, it's going to be APLOL from our direction. So I'm going to select number 3. Okay, number 3, and there it is, enter. Press enter, and then I'm going to do flight plan, and then I'm going to go, it's going to go to pitch hold anyway, that's not a problem. DTO, let's go to APLOL, which is number 1, enter. So now you can see that the routing has changed. You can see the FMS has adjusted from runway 32 from present position to APLOL all the way to APGOX and APDIT. Okay, now we want to look at the vertical speed required to descend to APLOL. So I'm going to go to VNAV, VNAV, VTO, and let's see what APLOL is giving us. Can you see this? To go to APLOL from our present position, we have to have a descent rate of how much? 2,517 feet per minute. This exactly proves the point that I was saying. When you are assigned to go to a runway furthest out, and then there is a runway change to a closer runway, your vertical speed to descend to will increase because you are closer and you are higher. And this completely proves the point here. You can clearly see that all these vertical speeds are higher than if we were to go to runway 14. Okay, that's the whole point, the purpose of this exercise. All right, so in this case, what would you do if you are given runway 32? What you would do basically is, first of all, you would definitely go heading select. All right, so you will go to heading select, which is here. All right, and you're going to go to vertical speed. Okay, and then what you will do, you will set the aircraft to point towards runway 32. Now this will be done well before you program the FMS. The reason why I programmed the FMS is to show you the vertical speed concept, because as you remember, I told you that if you are going further, the vertical speed is less, and if you are close and high, the vertical speed is more. Okay, so you don't want to dive down. So what you could do now, you are in heading select here and vertical speed. Now the same idea applies. What you will do is that you will set a higher vertical speed, all right, so that first of all what we'll do VNAV, VTO, and let's say we're going to AppLol. All right, so we can go to AppLol, and that's going to be our waypoint to descend to. Okay, and then we're going to go all the way down the vertical profile. Okay, and once you do that, you then catch up the vertical profile from below, doing the same maneuver that I explained to you in the just the previous presentation on the same video. Okay, that's the main thing. So some things can be a bit different here, but normally if I can even do VTO, let's say for example to position update. Okay, VTO. Okay, see now this is where the difference is, that in this software we have to cancel the VNAV and then VNAV again, and then we have to go to present position, from present position to update. Update is the final approach fix runway 32, and I'm going to press 5, and that's what gives me here at this rate of descent. Now it says target vertical speed is too low. Of course it's too low, you can see that, you appreciate the fact, but if I set a higher vertical speed, let's say 2000, it may accept. So the whole point is that if you are close and high, you need a higher vertical speed to descend to. All right, and then you can see that from present position now it's going to work out top of descent to update. Okay, now here you'll require 2000 feet per minute. Can you see what's happening here? So this is FMS doing everything for you. Now you don't have time to program the FMS when you give runway change, because when you give a runway change you immediately need to act. So you reduce your level of automation from the LNAV VNAV to heading select and vertical speed. First fly the aircraft in those two modes, heading select and vertical speed. Then while the aircraft is descending below the FMS flight path, vertical profile rather, to the assigned runway, you can now start adjusting the FMS and then come from below and capture the path. That's all I wanted to show you in this presentation. I'm not going to run the simulation, don't need to, but just remember that this is what you could do if you are given a sudden runway change. Either orbit, descend in the orbit to capture the profile, or use vertical speed, set a higher rate of descent and go below the vertical profile until you get a suitable value to where you're descending to, let's say 1005, 1800, then you decrease the rate of descent to that value given on the FMS using your thumb wheel on the FGCP. So you'll pitch up, your indicated airspeed will decrease, you'll be within the configuration regime, and then you'll be all good to go ahead and land. On the contrary, if you are coming into runway 32 and you were then assigned runway 14, now you know you are far out and you are low. So instead of increasing the vertical speed, you'll reduce the vertical speed. Okay, again heading select vertical speed, and then you can reprogram the whole FMS to give you the LNAV profile and the VNAV VTO profile to the final approach fix. So I hope that this presentation has made a bit of sense. The software which I'm using here is a bit different to what it gives you in the actual aircraft, but I think the concept I'm hoping is understood. So just remember that. Until the next one, be safe, and then I'll try and post some more videos as we go along. Thank you.